Assalamualaikum and greetings everyone. Welcome back. Now let's look at a few examples on line integral of vector field. Let's start with example A. So here we are asked to evaluate line integral f dot dr where f is equal to x cubed yi plus x minus yj, and your curve is given as y equals x squared from point -2, 4 to point 1, 1. So this is the case where your curve is given as y as a function of x. So what we need to do is we're going to use case number 1 where we need to change everything in terms of x. Y here must be changed into x, and so is dy dx. And the limits we're going to use for the limits we're going to use the x coordinate of the initial and the destination points. Okay, so here we have our vector field f and our curve c. So from the notes, f dot dr is going to be a line integral in a scalar field where pxy is our x component of our vector field f. So that is going to be x cubed y dx plus x minus y dy, okay, along curve C. So now, since our curve is given as y as a function of x, we need to change everything in terms of x. So from here, if y is x squared, then dy is going to be equal to 2x dx. Okay, let's change all the y's into x. So here we have x cubed remain as x cubed, but this y here must be replaced by x squared. Dx is still dx, and then here we have x minus y, so this y here must be replaced by x squared, and dy here will be replaced by 2x dx. Okay, now let's get the limits for x. Here we're going to use the x coordinate of the initial and the destination point. So here, this is the initial point, so the x coordinate of that is -2. That would be the lower limit. And here, this is the destination point, and the x coordinate is 1. So upper limit is 1. Alright, so now we're going to evaluate this. But first, let's simplify our integrand. Here we have dx and 2 dx there. So we're going to make that, and we're going to factor that so that we only write dx once. So here we have x to the power 5, simplify that, and here we have 2x squared, and here we have 2x cubed dx. Alright, so we know how to integrate this. Okay, now integrate this with respect to x. The first term will give you x to the power 6 over 6. The second term is 2x cubed over 3. And the third would be x to the power 4. 2 over 4 is 2. Okay, and then replace x with upper and lower limits. Okay, remember upper limit minus the lower limit. Now replacing x with upper limit 1, so we have 1 over 6 plus 2 over 3 minus a half, that is upper limit, minus the lower limit, -2 to the power of 6 is 64. And here we have -2 to the -2 cube is -8. So we have here minus 16 over 3. And then -2 to the power of 4 is 16 divided by 2 is 8. Okay, simplify this, we get, 1 over 6 plus 2/3 minus a half minus 64 over 6 plus 16 over 3 plus 8, and the answer is 3. Okay, so that is our first example for line integral on xy plane. Alright, now let's look at the second example. Okay, in the second example, we have, okay, I'm going to skip B here. I'm going to go straight to C, because for B, all the If you understand C, definitely you will be able to evaluate B. So I'm gonna give you one example for line integral in XYZ space and one in XY plane. Okay, so I'm gonna skip B. I'm gonna go straight to C. Okay, so here we are asked to evaluate f dot dr. This is our f and this is our curve C given in vector valued function. And our initial point is at 0, 0, 0 and destination point is at 1, 2, 1. Okay, all right, so this is our f, vector field f. And here we have a vector valued function r representing the curve. Okay, so from here we know that x is equal to t squared, okay, and y is equal to 2t and z is equal to t. Since this is a line integral in xyz space, meaning we have to change everything in terms of t. Okay, dx is 2t dt. Differentiate y, we get dy is 2 dt and dz is dt. Okay, we want to evaluate f dot dr over curve C. Okay, so this is going to be equal to, so this is in 3D, which means that we need to use this. So this is our f dot dr. So f dot dr will be reduced to this. Okay. Alright, so that would give us, in our case, it will be y squared minus z squared dx. Okay, plus, oh, it's going to be minus here. We have minus 2yz dy plus x squared dz. Alright, so now we need to change everything in terms of t. Need more room, so I'm going to write it here. Okay, so y will be replaced by 2t. So we have 2t squared, which is 4t squared. Okay, never mind. Let's stick with 2t squared, squared again. And we have z. Z is equal to t. So square that. Hang on. This is wrong. Y is 2t. Y is 2t, and then we need to square that. Okay, and then we have dx. So dx is equal to 2t dt. Okay, then we have minus 2y. Y is 2t and z is t, and dy is equal to 2 dt. Okay, next we have plus x squared. So x is t squared. Square that, we get t to the power 4, and dz is equal to dt. Okay, so you just replace x, y, z in terms of t, including dx, dy, dz must be replaced in terms of dt. Okay, now we need to get the limits for t. Okay, but in our question, it gives us the initial and destination point using coordinate, the Cartesian coordinate. So now we need to get the value of t at 0.000 and also the value of t at 0.121. Okay, so here, I'm gonna change it here. Alright, so x is equal to t squared, y is 2t, and z is t. Okay, our initial point is at the origin where x is 0, y is 0, z is 0. So straight away you can see that at 0.00 t is 0. Okay, because here we have t equals 0. T squared equals 0. So squared 0 times 0 squared is 0. 2 times 0 is 0. Meaning that our lower limit for t is, lower limit for t is 0. Okay, now let's look at our destination point. Destination point is 1, 2, 1. Okay, I'm gonna save some space here. I'm gonna erase this. Okay, our destination point is is at 1, 2, 1. Okay, straight away from there, using this, you can see that t is equal to 1. Okay, let's check for the y coordinate. 2 times 1 is 2. 1 squared is 1. So at point 1 to 1, the value of t is 1. So that would be the upper limit for t. Alright, so all the terms here have dt, dt, dt. So we're going to factor dt out. Okay, so if we factor dt out, then for the first term we have, that would be 4t squared minus t squared, that would be 3t squared, and then multiply with 2t, that would be 6t cubed. Okay, and the second term we have minus, here we have 2 times 2 times 2, that's an 8, and here we have 2t, so t squared, and the last one is t to the power 4, and then we factor dt out, so we end up with this. Oops. Okay, that's easy enough to evaluate. Alright, so first term is equal to 6t to the power 4 over 4, or 3 over 2, and here we have 8t cubed over 3, and here we have t to the power 5 over 5, and then replace t with upper and lower limits. So here we have 3 over 2 minus 8 over 3 plus 1 over 5 minus lower limit, we have 0. So simplify this, we get, hang on, 3 over 2 minus 8 over 3 plus 1 over 5, and we get negative 29 over 30. Okay, so that is the answer. Alright, so for line integral of a vector field in x, y, z space, you have no choice, you have to change everything in terms of t, including the x, dy, and dz must be changed in terms of dt. Okay, 2 examples. Thank you.